So we're going to start by just graphing ordered pairs and labeling them with the corresponding letters. So first we're going to graph -4, 5, and that's going to be point A. So the first number tells you what to do left or right. Second number tells you what to do up or down. So we're going to go left 4 and then up 5. We're going to put a point and label it with an A. All right, same thing on number 2. We're going to go side to side 0 this time, and then up 7. We're going to label that one with a B. Next, we're going to go right 6, up 9. So right 6, up 9. We're going to label that one with a C. Next, we're going to go left 3, down 7. Left 3, down 7. I'm going to label that one with a D. To graph number 5, we have to go left first, and then we're going to stay there. So left first, up and down 0, stay right there. We're going to label that point E. And number 6, point F, is going to be left 7, and then up 7. Left 7, up 7 will put us right here. And we're going to label that one with an F. I'll leave those up there for a second. Any questions on those? So number 7 is just sort of like a background question to see if you know what you're talking about. So how do we find rate of change? And these will be really good when you're studying. Sort of. Rate of change, we usually, like how do you find it? You're going to subtract the y's on the top, and then you're going to subtract the x's on the bottom. So we'll do that for number 8 and number 9. It doesn't really matter which way you subtract. I think we've done both in this class. I usually go from the second one back to the first one. So -4 minus -2 over 2 minus 1. That would give me -2 over 1. And then you do the same thing again for the next two. So -6 minus -4 over 3 minus 2. I'm getting the same thing, -2 over 1. And then finally, we'll do -8 minus -6 over 4 minus 3. And again, that's going to give me -2 over 1. So is the rate of change constant? Your answer would be yes. I'm going to try to squeeze it in over here. Yes. And then what is the rate of change? It's -2 over 1. You could write it as just -2 if you want. You can make it a whole number. Usually slope and rate of change I like to keep as fractions, but yes, for sure. So you can see there's a lot of work that goes into each of these. Well, if you want, I just circle and do the arrows so you can see what I'm doing. If you know what you're doing, you don't need those. They help me keep my work straight, though. All right, I'm going to do the same process on the next one. So 9 minus 6. Try to write a little smaller this time. Over 3 minus 1. It's going to be 3 over 2. Next we have 14 minus 9 over 4 minus 3. So 5 over 1. Okay, what happens when you can see that they're not the same? You can stop and just say no. The rate of change here is not constant. the rate of change is changing. So it's not a constant rate of change. Once you notice that, you can just say no. I always go back and double check though, just to make sure I didn't like accidentally subtract wrong. So yeah, 3 over 2 and 5 over 1. So yeah, it's not going to be constant on that one. All right, and then number 10 is just preparing us for the next section. It asks how to find slope when you're given a graph. Remember, slope, we use an M. So when you're looking at a graph, we say it's rise over run. And that should finish up the front page for us. Any questions? So on number 11, we are supposed to find the slope of these lines. So line A is first. I'm going to count the rise. So 1, 2, 3, 4, 5, 6. Then I'm going to count the run. 1, 2. So every time I go up 6, I'm going right 2. You can reduce that to 3 over 1. Anytime I reduce it and I have the graph, I go back and check to see if that makes sense. So 1, 2, 3, 1. See how I'm still on the line? So that is usually an indicator that I did reduce correctly. And again, we wrote it on the last page, so I'll just remind you, we are just counting the rise and the run and writing it as a fraction. If you want to reduce that to just regular old 3, that's fine. Like I said, I usually keep rise over run as a fraction, 3 over 1. All right, same idea for part B. You want to start at the point and count to the other point. Remember, rise, it kind of makes you think you're always going up, but you can go down. It's just a negative. So 1, 2, 3, 4, 5, 6, 7, 8. I went down 8, so negative 8. And then my run is 1, 2, 3, 4, 5, 6. And that's to the right, so that's positive. Those numbers are both even, so I'm going to go ahead and reduce to negative 4 over 3. Again, you can go back and see if that makes sense. So if I start on that same point and I go down 4, 1, 2, 3, 4, and then I go right, 1, 2, 3. See how I'm still on that line? So I'm good to go. Okay, number 12 is another like helping you study, helping you prepare to do the next section. It asks how you find slope when you're given 2 ordered pairs. This is where you subtract the y's on top, so y1 minus y2, and you subtract the x's on the bottom. So on number 13, I'm going to call this x1, y1, x2, y2. Y's on top, starting with y1, so 10 minus y2 is 4. On the bottom, we start with our x1, so 5 minus x2 is 7. So on the top, I get 6. On the bottom, I get negative 2. And that will reduce to negative 3, or 3 over negative 1, or negative 3 over positive 1. Just depends where you want to put that negative. And if you want to keep the 1. I've said it a few times. I'm sure I'll say it a few more times. I always keep slope as a fraction. It's just the way I'm used to doing it. So I'm going to leave it 3 over negative 1. Questions? All right, let's jump to number 14. It's actually going down. So we have x1, y1 again, x2, y2. We want the y's on the top, so 5 minus negative 9. On the bottom, we want negative 1 minus 3. Oh, so that's what, 14 over negative 4. Those are both even numbers once again, so you can just divide top and bottom by 2. So that'd be 7 over negative 2. The calculator will do that reducing for you. You just use the ABC button. If anyone would like me to show them that either today or tomorrow when we do the practice test, I can. I cannot show you how to reduce using the calculator on the actual test day, so make sure you ask me now or tomorrow if you need it. All right, jump back up to 15. X1, Y1, X2, Y2. Subtract the y's on top, so 2 minus 4. And the x's on bottom, 5 minus 5. That's going to be negative 2 over, 0. Can you divide by 0? No. If you put it in the calculator, it will tell you error. That's when you know that it is undefined. So if the calculator says error, your answer is undefined. And you can just put UND period. Now, that is not the same thing that's going to happen on 16. On 16, we have x1, y1, x2, y2. On this one, you can see that we're going to end up with the 0 on the top. What's 0 divided by anything? No, it's not an error. What is it? 0, yes. So when 0 is on the top, 0 is your slope. When 0 is on the bottom, your slope is undefined. All right, I'll give you guys a second to catch up with that. The directions for 17 through 20 say graph using a table. So this is where you do x and y. Remember, we get to pick the x's. I'm going to pick 0, 1, and 2. You plug that in for the x in the equation, and you do the math to find the corresponding y value. So I need to do y equals 4 times 0. Then I need to do y equals 4 times 1. Then I need to do y equals 4 times 2. That will give me my 3 ordered pairs. What is 4 times 0? 0. What is 4 times 1? 4. What is 4 times 2? 8. Good. Those are the ordered pairs. Those are the dots on the graph. Okay? So 0, 0. So left and right 0, up and down 0. 1, 4. So right 1, up 4. And then 2, 8. So right 2 and up 8. Once you have 3 points, whoa, that is way too thick. Let me get a more reasonable width. Still a little large, but there you go. Connect them and put arrows on the ends. Remember, this is a visual representation of all the solutions to this equation. So all the ordered pairs that would make this true would fall somewhere on this line. That's why we need the arrows on the ends, because the numbers keep getting bigger and bigger and bigger, smaller and smaller and smaller. Any questions? Anyone need more time with number 17? All right, so next let's do a table for number 18. So we have y equals x minus 3. Once again, we get to pick the x's. We do some math to find the y's. I'm going to do 0, 1, 2. So the math I need to do is 0 minus 3. What is 0 minus 3? Negative 3. So when x is 0, y is negative 3. Next, I need to take the x out and put a 1. What's 1 minus 3? Negative 2. So when x is 1, y is negative 2. And finally, one last time, take the x out, put a 2 in. What's 2 minus 3? Negative 1. Those are my 3 ordered pairs. So left and right, 0 down 3, put a point. Right 1 down 2, put a point. Right 2 down 1, put a point. Once you get your 3 points, connect it with a line. Arrows on the ends, and you're good to go. So 19, the math is getting a little more complicated, but it's the same process. X and Y, 0, 1, 2. Now you just have to multiply the X and add. So we'll have Y equals -2 times 0 plus 5. -2 times 0 is 0, and 0 plus 5 is 5. We'll do it again. -2 times 1 plus 5. -2 times 1 is -2, and -2 plus 5 is 3. And then last we'll plug in the 2. So -2 times 2, that's -4. And -4 plus 5 is 1. So again, I got 5 here, I got 3 here, I got 1 here, and then those are the Y values that go with whatever that X value was that I plugged in. Once you have all 3, you can graph them. So 0, 5, left and right 0 up to the 5, put a point. Right 1 up 3, put a point. Right 2 up 1, and you put a point. Connect it. Arrows on the ends. We're good to go. So number 20 is on the next page, but same idea, XY chart. 0, 1, 2. So we'll take out we'll take out the X, we'll put in a 0. There's really no such thing as a -0, so it's just going to be 0. Next, we'll take the X out and we'll put a 1, so Y is going to be -1. Then we'll take the X out and put a 2, so Y is going to be -2. So basically, the sign is just changing. So the Y is always the opposite of X. It's just -X. We've only plugged in positive, so all of our Y's are going to be negative, with the exception of the 0. So graph 0, 0, +1, -1, so right 1 down 1, right 2 down 2, connect, arrows. So when we graph using M and B, we have to remember the form Y equals MX plus B, where this M, the number right in front of the X, represents our slope. Remember, slope is rise over run. And then the B represents our Y-intercept. That's where we start on the Y-axis. So I'm going to list M and B for each of them, and then I'm going to use those values to graph. What is the M on number 21? The M is always right in front of the X. 2. And I'm going to write it as a fraction because I need a rise number and I need a run number. Anytime you're making a whole number a fraction, you just put a 1 on the bottom. And then what am I adding on the end here?
1.
Nope.
7.
Nothing, right? And nothing in math is 0. So we're not adding anything on the end. So B is 0. So on the Y-axis, you're going to start at the 0. From the 0, you're going to rise 2 and run 1. From that new point, you're going to rise 2 and run 1. So your graph should look like this. You start at the 0 on the Y-axis. Your Y-intercept is 0. Rise 2, run 1. So up 2, right 1. from that new point up to right 1 again. These go a little quicker. There's no calculation involved. You know, you just pull out the M, you pull out the B, and you graph. Number 22, I need an M and I need a B. What's my M? 1 over 1. Yes, if you don't have a coefficient with your X, you know it's like having a 1. It's like a 1X. But I want it as a fraction, so 1 over 1, and then what's my B? 6. So I'm going to start on the y-axis at 6. Remember I told you the B is where you begin. Begin at the 6. On the y-axis. From there, I'm going to rise 1, I'm going to run 1. I'm going to rise 1, I'm going to run 1. Once you have your 3 points, go ahead and draw your line. Arrows on the ends. Make sure when you're doing this on your test, especially Thursday, that you're using something straight. I can get some rulers out, I can give you a note card, you can use the side of your ID. But these are a lot easier to grade and easier to graph when you're using something straight. Questions? Yes, the M is 1 over 2, which is great. I love when slope is already a fraction. It just makes everything easier. What are they adding on the end, though? Nothing. So a 0. So start at 0 on your y-axis, which also happens to be 0 on the x-axis. They're the same. From there, I rise 1, I run 2. Rise 1, run 2. Once you have those 3 points, go ahead and draw your line with the arrows on the ends. All right, last M and B. Notice there's a negative in front of the fraction. Where should I put it? Either one. I usually put it in the top, just so I know I've taken care of it. If you want to put it in the bottom, that's fine, but don't do both. And then what's my B? 1. So I'm going to start on the y-axis at the 1. From there, I need to go down 5 and then right 3. So down 5, 1, 2, 3, 4, 5, right 3, 1, 2, 3. I'm going to put a point. Do the same thing again. Down 5, 1, 2, 3, 4, 5, right 3, 1, 2, 3. Put a point. Now I'm going to show you over here in another color. If you said that the M was 5 over negative 3, that's completely fine. You would just be going up 5 and then left 3. And look, when I go to connect these, that's still the same line. So you're good. If you went up and left this one, or if you went down and then right this one, either way is fine. You'll end up right along that same line. What are your questions on number 24? So remember, when you're graphing special lines, you'll only see one variable. That's the tip-off that this is a special line. And my trick is to remember that that's the axis that you're going to cut across at this point. So I'm going to count up to 5 on the y-axis. I'm going to shoot right across it. Boom. What are your questions? All right, same idea on the next one. I'm going to cut across the x-axis at the point -2. So left 2, cut right across it. And remember, those are special because there's only one variable. It's either an x equals some number or a y equals some number. Questions? All right, and then these last couple, you can graph any method that you want. Does anyone have a method of choice? X and Y. I'll take it. 0, 1, 2. So y equals 5 times 0 minus 7. 5 times 0 is 0. Minus 7 is negative 7. Do it again. 5 times 1 minus 7. 5 times 1 is 5. And 5 take away 7 is negative 2. And then one last time, but with the 2 in for the x. That would be 10. Minus 7, that would be 3. We now have 3 points. We can get those on our graph. So 0, negative 7 would be left and right, 0 down 7. 1, negative 2 would be right 1 down 2. And 2, 3 would be right 2 up 3. 3 points. That's the perfect number. Connect them. Arrows on the ends. Now, just a little side note, I said you get to pick the method, so you could have done M and B. Here the M would have been 5 over 1, the B would have been negative 7. So you'd start down at the negative 7 on the y-axis, and you would count up 5, right 1. Oh, look, there it is. Up 5, right 1. Oh, there it is. So if we just look at the graph, we shouldn't even be able to tell which method that you used. However, your work needs to reflect whatever method you've chosen. So we should either see a table or we should see some information on what M and B you used. Questions on that? These are kind of tricky where you get to pick the method. All right. This is the final question for this review. How am I going to graph this? Go to 1 on the X or the Y? The Y. And then do I want to go up and down and like be the y-axis, or do I want to go left and right and go through the y-axis? Left and right. Very good. All right. Arrows on the end. So today's review, I think, all of the talking. Probably like 98% of the talking. That was on purpose. I want you to know exactly and perfectly how to do each of these problems, because tomorrow I'm setting you loose on the review. It's a practice test. You're going to come in, you're going to get to work, you're going to work by yourself, on your own, the entire thing. And then Wednesday we'll grade it together, and then Thursday's the real deal. So hopefully, even though I was just droning on and on and on, hopefully you were able to listen. Are there any questions or problems you'd like to see again? We've got a couple minutes.